out like the carrier. There's just a big group.
All right, let's go ahead and get started. Welcome to the July edition of Code and Beer. Today we have Alex Schmaltz. He's going to be talking to us about the future of JavaScript. That's going to be a PechaKucha. For those of you not familiar with PechaKucha, although I think most of you except for Booth here are familiar. 20 slides. You have 20 slides. Each slide is 20 seconds, and you have no control over when the slides advance. They just go on a timer. Or do they? There you go. So that'll be good. And then Chris Fahey, Fishbowl Fahey, building test-driven JavaScript components.
Don't want to miss it.
Yeah, this is a cool one. He presented at StirTrack, and now he's going to grace us with his presentation. And then next month, we have Git, a play. Well, next month, Kevin Mack and Eric Katz are putting together a play on Git. I have no idea what they mean by that. Well, sort of, I have an idea, but it should be entertaining. It's going to be a play. It will be a performance on Git. So we'll see what that is. And that's all we have on our agenda. So over the next few months, weeks, days, whatever, we're going to be reaching out to people in the practice to try and fill out our backlog for presentations. I'm sure a lot of you in your goals for the year have presentations in your goals. So this is a really good opportunity to fulfill that goal. And one of the core principles or foundations around this group is to give people an opportunity to practice presenting in front of people so that you can present out to external groups. So be thinking about that too. So yeah, we'll be reaching out. If anyone has any ideas or wants to volunteer, reach out to myself, Wes Lewis, Myra Vargas, or Kevin Mack. And if you need ideas for topics, you can reach out to us on that too, or talk to your TLs. So, Alex, if you're all set.
Do what? Shut up, Ben.
That actually means something else.
All right. Ready? All right, so I'm going to talk about the future of JavaScript. I'm Alex Schmaltz, the front-end developer here. I was struggling trying to find a topic, so I talked to Kevin Mack. He's like, dude, do ECMAScript. You're talking about it before, do it. Terrible choice. Never listening to Kevin Mack ever again. Shouldn't have started. Anyway, before we get to the future, we'll talk about the history. Brandon Ike developed it in 1995, allegedly in 10 days. I don't believe it. Called it Mocha. Netscape Navigator later called it LiveScript. Then it became JavaScript. And meanwhile, Bill Gates is pushing it. We need standards. We need standards. That's where ECMA comes in. 1993 is when the baseline kind of started. Had a troubled start. ES4 from 2000 to 2008. They attempted it twice. It failed. Trying to move too quick. It didn't feel right to developers. ES5 is where they hit it, and JavaScript started to grow exponentially. They added like JSON. That was kind of when that emerged. So it's formerly ECMAScript 6. They decided to call it 2015. What it is, JavaScript is the actual implementation. ECMAScript is the specifications or documentation. And ECMAScript 6 is the next standard for JavaScript. Why? JavaScript's being used for more than it's intended. They need to update it. So who's ECMA? They're a standards body. Specifically, TC39 is the team inside making the standards for JavaScript. It's an organization of major browser developers, guest experts. Google has their hand in it, and wizards and magicians. And they're very slow. They just started using GitHub 2 years ago. Before that, they were using Word. So can I use it yet? No, kind of, maybe, but no. Some browsers have ES6 features like Chrome, but you have to go in and actually enable experimental JS. Don't do it. You can also use compilers or transcompilers, Gulp and Grunt, Babel. CodePen has Babel now. You can mess around with it there. What's new? All of this, more than I can fit in my presentation. Thanks, Kevin. Basically, there's a whole bunch of different features. I kind of chose ones that I see myself using, some things that I find cool. Who knows? There's a whole bunch of stuff. All right, contains. This is one of my favorite because I'm so tired of using index of. I use this like 1 billion times a day, and it doesn't make sense to me. Index of b greater than -1. Why? So now you have the contains. ABC, if it contains b, it's going to return true. That makes sense. It's in English. All right, Felicia.
Good use.
Arrows, another one of my favorites. Shorthands for function declaration, very CoffeeScript X. Here we have, function X, return X times X. Instead of that, we have X arrow, return X times X. Just making things simpler on the developer. When it doesn't have params, you actually include empty parens, kind of weird, whatever. Block bindings, this is interesting. The let variable, it declares like a variable, like var, except it's restricted to its current block. So, you can change things in blocks. And you also have const variables. Like here, I'm using the example pi. It's going to be a constant. It's always going to be the same value. It's not changing. They also added destructure assignment. This is several variables initialized in a single statement. Here we have day, month, year, 13/2/1963. But this is America, so we're using month, day, year. And you can switch the order around of those keys. It doesn't actually affect the variables. It's kind of like a mini database, if you will. Parameters, default parameters. They assign a default value to function params, and used if parameters not formally passed. You can set these up, and you can change them if you want to pass in a variable. If not, that's the default value. We also have rest parameters. That's going to replace use of arguments. And spread is the opposite of rest. It splits an array. Oh, these are fast. Iterators, objects that have a next method inside of them. They return a value, and they return a done statement. And you can also use the for of loop, which is new. So, we have this variable with 1, 2, 3. We're able to loop through that, and at the end of these, there's a next statement telling you to go to the next value. Generators, they return an iterator by inserting an asterisk after a function keyword. The new yield keyword is used to specify values that iterator should return when next is called, and it'll stop execution until next is called again. So here we're going IT2 next. It's getting the next yield. Collections. So we have sets now, and these are simple data structures. They're similar to arrays, but each value is unique. So you can add a value. You can see if it has 4, which will return true, false. You can add a 4, add a 2. You can delete a 3. You can mess with this. Again, it's kind of like a very mini database, very object-oriented. Symbols. They generate a unique inaccessible key. Very weird thing. I'm not exactly sure how I would use it yet, but it's kind of cool. They're useful in maps and class private members. Basically, it's creating a variable that you won't change. And they also added weak maps and weak sets, and that's for cleaning code. It's called weak sauce. Template strings, new string declaration, uses backticks. The cool thing about this is you can have like a string of text, and if you're clicking enter in your code, it's actually going to spit the code out as different lines. Finally, promises. This is kind of what is doing or changing callbacks. People are saying it's doing away with callbacks, but it's really the same thing. JavaScript single-threaded, humans are multi-threaded. Previously, we had to work around JavaScript single-threadedness, and this sucks when you're using these functions on many different things. Now we can set up a promise and we can refer back to it. It's also a library for asynchronous programming. First class representation of a value that may be available later. Promises are already used in like many JS libraries. Here we're setting up a promise and we're telling it to reference that promise. So you can reuse these as callbacks. Proxies, this is kind of interesting. They allow creations of objects through other objects, exactly what a proxy sounds like. Here we're setting up a new proxy with a target and a handler to refer back to our variables, target and handler. So we're actually able to change these values through another variable. Kind of cool. Anyway, that's it. That's all the features I thought were really cool. I listed my sources, and I'll post these slides to Yammer. It's kind of worth checking out. Now it's going to start picking up speed as browsers are embracing ES6. So Some cool features.
Yeah.
Let's get fired up. I'm in it, watching it.
Hey, with that, you click the video, not the hangout.
Oh shit.
What
You can set that down.
determines
You just drop it.
what object you can set?
Oh, that was nice.
Uh-huh.
Is it doing a reference comparison? Or will it compare the values of that object, or do I override like a equals? You know what I mean?
In a set.
Like say I have like a person object
Yeah.
that I shoved in there, because it wants this person to be unique. I wonder if it's doing some nice stuff, like if all the properties are the same, rather than the reference. You know,
if it's a number or a string, it's probably the value comparison.
It does,
Otherwise,
It is able to hold all of them, so you can do numbers and strings.
You may want to mute your mic.
yeah, I just wonder what it's using for equality.
Yeah.
You know what I mean?
No, I get it, exactly, yeah. I'm just occasionally gonna switch over to
If it does like a-
selfie cam.
It's gotta be like the double.
Okay.
Laptop while he's presenting.
Cool.
We're gonna, yeah.
How probably
Does it go?
And this is like my first go.
On the hierarchy.
Oh, common.
You want us to video?
Yeah, you got yours here.
No, it's because it's Alex.
What?
Oh, you're not? Oh, not yet.
How you getting Alex's face on there?
I'm still broadcasting?
Oh,
because he's.
I didn't think I'm not there yet.
I know. I just said it was recording directly from his cam.
It's equal.
Yeah, you're still like big, yeah, Chris.
I'm not connected.
Yeah.
Oh, that's weird.
So good luck with that. I'll send you another.
Bam, hold on, I got it.
Oh, wait, there you go.
I had to click join twice for some reason. I'm not muted.
Okay, so when you present, we'll do select your presentation through slide, or, display.
Can you select my?
Let me go back to Hangout, a little on the left. There's the blue green.
Spell color. Screen 2. All right. Let's see what's going on, yeah.
All I see is a blue screen. I think you should. Oh, there you go.
There we go.
So the first article I came to is.
Let's see here. All right. Let me get this set up. How we doing on time? Hour? All right. I should be less than that. All right. Don't worry about it. All right. All right. Let's go ahead and get started. This is not my sister. This is a girl named Testing, and she had 26 unit tests passed. So if you dig chicks that write unit tests, swipe right. Okay. I did not say that at Stir Trek. I can tell you that much. Why is this not? There we go. All right. So before we start talking about whose favorite programming language, JavaScript, let's talk about some low-level stuff in testing. So is anyone familiar with Apple's go-to fail bug? What it was, when it happened, what was the deal? Basically, the go-to fail bug was discovered the same time as Heartbleed. Go-to fail was shipped in OSS Mavericks around September of 2014, and it wasn't figured out until, September 2013. It wasn't found until like February 2014. There were basically 18 months. It was on millions and millions of devices. And what happened is that during the SSL handshake process, it exited prematurely. It never went to the final step of the three-way handshake. So what you have here is all these if statements. They go through their hashes, their handshakes. You have this double go to fail. There's no curly braces. Some people are like, well, if they did curly braces, this extra go to fail would have been found easier. Some people were saying, well, this is an unreachable block of code. If there was a compiler flag, you would have had an unreachable block of code. If you are using JavaScript and code quality tools like JSLint, Hint, whatever, it would have said, hey, you have an unreachable block of code. It is. I'm not too familiar with this low level stuff. This will never hit because it always hits here if there's an extra go to fail. So so even if this if is false, it'll skip this and just hit that. So it'll never reach there. So the impact of this isn't known because you don't know how many people exploited the handshake and did a man-in-the-middle attack. There's a pretty good article that breaks it down right here on this on CodeCentric. They were focusing on curly braces. And I was just like, why are you talking about curly braces? Like curly braces is not going to stop something like that from happening. A compiler flag may have been about unreachable block of code, could have been ignored. Bob Martin broke it down. He mentioned it in an article he wrote about testing culture and why it's important. To me, I found as testing extremely important, especially in this use case, because this is an algorithm for ensuring secure communications. This is just one piece of the algorithm too. If they were writing unit tests or some kind of tests that say, hey, our algorithm works like this under these conditions and it fails under these conditions, this unreachable block of code, this final handshake would have stood out like a sore thumb. It would have been like, hey, our algorithm isn't working the way it's supposed to. My assumption on this, because this has happened to me many times, I feel like this got into code, not because maybe they were doing a code review and both coders missed it. I don't know. I feel like this was a copy and paste fail. This is just one area of code where they're doing all these ifs statements. Uncle Bob talked about refactoring this code to make it better so you're not repeating yourself. But I feel like since they were repeating themselves so much, they were copy and pasting code and they copied a block and when they selected, that's my hypothesis. It was a copy and paste fail that impacted potentially millions of people. So the testing of this, I think the entire bug could have been avoided if there were tests. I'm not saying they didn't test, but if you were testing your algorithm saying, this is the way I am expecting my code to work, the way to pass and fail, I believe this would have never happened. Back to JavaScript though. So JavaScript, as Alex touched on, it 20 years old, just happened. Pretty basic programming language to do simple manipulations of web pages, but it has grown into more complex and scalable apps, hence the entire point of ECMAScript 6 coming through. Why are they adding all these quote unquote unnecessary features? Well, as things rise in complexity, you need those features such as interfaces and classes. You don't always want your variables function scoped. Sometimes it's nice to have a block scope variable, so let's introduce the keyword let. Basically, JavaScript, there's tons of client-side code, and it's proven itself as a programming language that can build complex apps. I'm not saying that all applications should move all their code to client-side. I'm not saying that all applications should be written in JavaScript. JavaScript on the server and JavaScript on the client side. You're going to have to strike the correct balance between having JavaScript code on the client side and backend code for validations, data access, and stuff. You're always going to try to battling both, but you're never going to want to put 100% of the code on the front end or 100% of the code on the back end. If we have time, I'll show an example of that. Specifically speaking about testing, if you were to have a component on your web page like Clippy, how would you test that? What is one thing you would test with Clippy? Maybe it's the message he says. Maybe there's a helper function says display message and you pass in a string. Or maybe he animates and does some stupid squiggly weird thing and you want to test that he actually animates. When you're testing JavaScript or in any programming language, you want to test data and behavior. It's fundamental object-oriented stuff. Any class, object, entity, whatever you want to call it, it has data and it has behaviors. If you're testing that, it's really easy to do in JavaScript. So this is a naive way of doing it, but let's say you've never tested in JavaScript before. You can have a simple function that returns a string. You can then basically invoke that function or exercise it, and then say, hey, I'm expecting this. And then you can just write to the console, hey, I'm testing this function, and true or false, does it work? Is it returning what I'm expecting? This is not scalable, but it's that easy. It's not difficult. You wouldn't want to write you wouldn't want to test an entire application like this, but that's how easy it is to get started. Importance of testing. So when you download jQuery or underscore or JavaScript file, whatever that does whatever for you, would you want to use some code base that has no test for it? Think about underscore. Hey, I'm expecting underscore to iterate over a collection and pluck out what I'm looking for of that collection. Would you want to use it if it had no tests? Basically, when you use another library on the internet, you trust that it works, and then you find the edge cases where it doesn't necessarily work in your use case. So if you're delivering code to your application or to your client or for your own startup, would you want to have no tests for your application? If you wouldn't want to use jQuery, you just trust that it works, but you don't have as much confidence in a library if it has no tests. So just think, would you want to use someone else's code that has no tests? Think about what you're delivering. Do you want to deliver something that has no tests? An example of this, it's kind of hard to see on this projector, but this is Moment.js. Moment.js is simply a date manipulator, parser, displayer. It doesn't matter. It basically deals with dates in JavaScript. Moment.js, if you go to their website and go to their tests tab, they have over 45,711 tests passed that run in real time. If you go to that test, you will see, or this website right here, you'll see this run in real time. If you inspect their JavaScript and you look at their files, they have a JavaScript file that's like, I don't know, like 30,000 lines long or something ridiculous like that. And it's just ridiculous. And you can see this go, so they're even testing different languages. I don't know what AF is. Afghanistan's a country. I don't think that's a language, if anyone knows what AF is. But they're testing all these different ways of displaying dates in a different language and parsing and manipulating. Given some date, if I add 5 minutes, the time should be 5 minutes from now. If it's 7:56 and I add 5 minutes, it should be 8:01. They have 45,000 unit tests just for simple date manipulation. I had to do some date manipulation for this one thing I was building, and use Moment.js. I've heard about it. It does exactly what I want to. When I stumbled upon 45,000 unit tests, I'm like, this little thing is probably going to do exactly what I want it to and do it right. Sure enough, it did. Testing JavaScript is hard. Public or protected or private or all these kind of accessor methods, or it doesn't have, you don't open Visual Studio and create a test project. There's many different ways of testing in JavaScript. It's different than other programming languages where they're like, oh, just fire this up and it does it for you. There's more testing frameworks in JavaScript, sort of like MVC, than you can count on your hand. Why is it difficult? Well, in JavaScript, it's flawed because anything that's declared var and not in a function scope block is just necessarily, it goes straight to the global scope. And best practices don't use globals. You can generally ask yourself if something's a best practice. Well, what if everyone did it? What if everyone was using global variables on a page? You're going to get naming conflicts. You're going to be overwriting stuff. You're going to have far-reaching code that may impact your code. Closures. So code that variables are function scoped. So this isn't a function, it's in a closure. You can't access this. So you can say name is private because anything outside of this function can't reach it. Anonymous functions. So in JavaScript, functions don't need to have a name. You don't need to give it a name. So you can say, hey, select this item in my DOM by ID, and when I click it, go do something. If you wanted to basically unit test your click handler, you wanted to run tests in like a console or some kind of browserless environment, good luck. because you're not going to be able to select an item by ID in a console in an automated way, maybe like a build process. When you check in some code, go exercise this stuff, you don't have a DOM there. But how do you test a function that doesn't have a name? How do you have code over here invoke your handler? You can't. Callback hell. This is something that Promises kind of alleviated, but callbacks and callbacks and callbacks. How do you test function 3 as a unit test? You can't, because it depends on function 1 and 2 being completed before you can test 3. Anytime you see something kind of absurd, where there's like, and this, and this, and this, it reminds me as like Exhibit. He's kind of poking fun of how obnoxious and wrong this is. So your code works. Sorry, what? So your code works, and that's great, but there's a better way of doing it. And we'll touch on ways that you can write your code in a better way, so it's more testable and scalable. Angular's on Angular's homepage, one of the first things they talk about getting into Angular is the importance of testing. So I'll show some code from Angular C project of, hey, when you write your app, your test scripts are right next to your implementation of your JavaScript file. So let's say you have a thing called like customer controller.js in some folder. Well, in that same folder, they say have a customer controller underscore test.js. Don't put your tests somewhere else. Put your tests for what you're building right next to it, because you should be writing your tests for your application as you're actually building your application. Angular also is suggesting, hey, the way you write JavaScript drastically impacts how testable it is. And that's what I was just touching on. Global variables versus closures. Anonymous functions. Callbacks and callbacks and callbacks. You don't have to write code like that. You can write code in a way that is very easy to test. Another thing that impacted me when I was starting to write tests is that it changed the way I write JavaScript immensely. We'll cover some testing basics. So unit testing, really quick: arrange, act, assert, simple. Red, green, refactor. I don't like the red, green, refactor triangle. I think it's wrong. Just because you have something fail and pass doesn't mean you should refactor. Refactor when it's necessary. I found myself kind of going through the red, green refactor phase, and I found myself refactoring code just to refactor because it was kind of there. I don't know. Unit test fundamentals. I'm going to skip over this pretty quickly because we're all pretty familiar with it. I spent a little bit more time on this than Star Trek, but the most important thing to me is this right here: test hard to reach areas of code. Does someone want to kind of explain perhaps what a hard to reach area of code may be?
Talk about your edge cases.
Edge cases? Okay, that could be it. What's an example of an edge case of code that's hard to reach? Okay, depends on the problem. So hard to reach areas of code. One hard to reach area of code that I found myself testing is after a web service call. When I was writing my code, if the web service call failed, I wanted to test what would happen. Well, in my environment, it was very hard to fake a web service call from failing. So instead of clicking a button 100 times and hopefully that one of those times is going to fail, I wanted to test the hard to reach area of code by unit testing just a failure case. So by the way I structured my code, I could call my failure function independently to make sure that the proper message is being displayed, or the proper message is being passed in correctly into the messages handler. Another area that was very helpful for unit testing of hard to reach area of code was the submit button to a form. But this form had about 35 fields. And I found myself filling out all the form fields, only the required ones, and then clicking the button to test one small thing. And then when something changed in that little handler, I technically had to manually go fill out all those required fields. I think there were like 20 out of them that were 35 required, just to click a little button. A hard to reach area of code is something like that. It's code that doesn't get exercised every single time the page loads or something like that. It's under these rare conditions that something fails. So required.js and Jasmine, these are two tools that kind of helped me restructure the way I wrote JavaScript and test it. So required.js, what required.js is, it's a module loader. When I say a module, it's basically a JavaScript file. It's any file that has a .js extension. You can consider that a module. In the module, what it will do is you will specify your dependencies. Required.js will say, hey, before I execute this code in this module, go download all my dependencies asynchronously. And once all those dependencies come back asynchronously and I have everything, then execute my code. So if you've ever been on a project where you have about 30 script tags, you could have used required.js or some kind of module loader and narrowed that down to only one script tag. And let required.js go get all those scripts, all those modules asynchronously, and let it manage all the dependencies. We'll see some examples of that. Jasmine is a testing framework. What Jasmine gives you is a lot of keywords, but it allows you to basically test your feature, describe what your feature should do, and then your unit tests. In Jasmine, they call it specs. It's a specification on what your feature or what your component does. It has a lot of common keywords such as before each. So before each unit test run, do this, after each, etc. So required.js, it has a lot of configurations. The most popular ones that I like is paths. So instead of saying script source equals blah, 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 jQuery 1.7.1.js, you don't need a JS because everything's a JS file. That's implied. But I can alias it to jQuery. Or if I need underscore, I can alias it to underscore. And you'll see when I'm defining a module, one of my dependencies is just underscore. So when I open up a JavaScript file, at the very top, I can see what this file depends on. I can see that, hey, this module depends on underscore. This module depends on jQuery and underscore. So what required.js will do for you is basically say, hey, before this block of code runs, make sure that jQuery and underscore are loaded. It's called AMD, asynchronous module definition. What you're doing is you're asynchronously getting dependencies, and your modules are defining what their dependencies are. Instead of having global variables littered throughout your JavaScript file, you know exactly what that JavaScript file is dependent on. So required.js helps you alleviate global variables, build JavaScript in a modular way, and then when you test it with Jasmine, you can individually test individual components. You'll see some code here. One thing that I'm about to go through is drop jQuery 1. Support. Once nationwide drops IE8 completely, I'm moving to jQuery 2.0. When we do that, what's going to happen when I upgrade to jQuery 2.0? I don't know. What I can do is change my config in one spot and then run my unit tests on my modules to see what breaks, if anything breaks. You're basically specifying something all in one place. All of my modules are just depending on jQuery. So I only have to change it in one spot. I don't have to open up every single one of my apps and change my script tag. So to create a module in required.js, this is what I meant by specifying dependency as an alias. When I say window.define, required.js exposes the define keyword, and you're basically saying, hey, I'm defining a module. This module is returning an object that has two functions, show date and get today's date. That is the behavior my module is doing. What I'd likely do is, in my unit test, is say, hey, whatever JavaScript file this is in, go out and download it, and I need to have unit tests for these two helpers, whereas today is my quote-unquote private variable. This is a very simple use case, but this is an awesome way of saying, hey, this JavaScript file depends on jQuery. I didn't have to open up a JavaScript file that has 200 plus lines of code and see what all the implied globals are. The global variable jQuery, you don't need to say window.jQuery. You don't need to say window.$. You explicitly know, hey, this jQuery, this array of dependencies right here, it gets mapped here. So whatever the jQuery object is, it's saying, hey, go download this jQuery JS file asynchronously, and when that's done, map it to this variable, and then exercise it in this code. So this is a module that is being defined. This is a Jasmine test suite. There's 2 unit tests in here. So we have an it and an it. So what I'm saying here is window.describe. This is a Jasmine function, and I'm saying this is my suite. This is my feature that I'm testing. In this suite of tests, I'm saying it should do 2 things. It should get current month, and it should get current year. That's the module we created. When we do this, we arrange, react, reassert. Pretty simple stuff. Get current year, you just go on and on and on. This is a pretty simple use case. How do you use Jasmine with require.js? So what we would do is we say, here's our date suite, but before each unit test runs, I'm saying require our date, that module we created before, go get a new instance of this date, map it to here, and then our module is new date. So it's kind of hard because it's asynchronous stuff going on, but then before we run get current month, what it does is it goes out, it asynchronously downloads date. If it's already asynchronously received our module, it stays cached. It's not going to go out and make another HTTP request or browser caches it. But then we have a new instance of our module. So the flow of this is describe.
No, I mean, where's the point module from? Do I find sources? Or does it go out on the internet? Because
right. So what you would do is you could either specify let me jump here. In this window.define, you could specify a full path to a content delivery network, and it'll go out and get that. In one of these config objects right here, you generally set your base URL. It assumes root. In SharePoint world, I set my base URL to style library. All your front-end code gets deployed to the style library. It doesn't get deployed to root. It's /style library. Then in my style library, it would be jQuery 1.7.1.js. So this config object there's tons of options for it. So let's say I have a jQuery extension called jQuery UI. jQuery UI depends on jQuery. So if jQuery UI were not implementing AMD, if it itself was not an asynchronous module, what we could do is say shim. Shim. So then you would say shim jQuery and then list its dependencies. Then you'd say jQuery UI. So then when jQuery UI is being loaded, jQuery UI will not execute until jQuery has asynchronously been available. This config is extremely, there's a lot of options. You can, in config, you can put set timeouts. You can say if this module doesn't download in 200 milliseconds, screw it. That's a nice to have. We don't need this. That's or not 200 milliseconds quick, but if it was like 5 seconds, all right, fine. Revert to the native date picker in the browser or something like that. That's one thing you could do. But what this is these paths. This would be more like something like base URL root scripts vendor jQuery. And you would specify that entire path there. But in your modules, you only need to say this alias right here.
Yeah.
So, and here, let's say we made a path called date. So that module we just talked about, describe, this module we created right here, define, this does not have a name. Its name is based on this file. So this would be called date.js. So what this would do is, hey, go look in our base URL or alias and download date, and then instantiate a new instance of it before each test case. That way we have a new instance of our object for each test case. and then after each unit test, set it to undefined so we know it's cleared. So that way, previous unit tests that I've run do not change the state of our object. This is one way how you can build a component and then test it individually. As a whole, this is your general flow. Let's say you had many features. You would say, describe this feature, some unit tests, this is what I expected. Here's another feature, and before each, go out and get a new one, after each, clear it, and so on. So as you have components, you're testing a component, all right, cool, test another component, and so on. So to do MVC, has anyone seen to do MVC? To do MVC. So JavaScript, there's like a million different ways of doing things. So there's like 60 plus front-end frameworks for JavaScript. To do MVC is basically all the different ways of building the exact same to-do app. So if you want to use Knockout, this is what it would look like in Knockout. If you want to use Angular, this is what it would look like in Angular. If you want to roll your own with just native JavaScript, that's what it would look like. It basically allows you to easily compare MVC frameworks in a simple to-do list. An example of this is they're using Jasmine for their unit test. So in order to have a successful to-do MVC app, it needs to pass 56 specs. Each one of these green dots is a spec. So they're saying our model and our view is a feature or a module. So in our model for our to-do app, it has two methods, create and read. The create method should create a to-do, and it should also fail creating a title list to-do. So this is where your describe expect it comes into play. You are describing your model, it is create, you're testing a function, and then you have many expects. And I'll show you this in a larger context, but then it goes on. So you're testing your model and your view, and then when your view, clear completed, shows and hides, should be hidden, should toggle on and add, should toggle on and hide and remove. So if you wanted to roll your own JavaScript framework and share it to the world and say, hey, if you want to use Lewis.js, what you can do is implement a to-do MVC, write tests for it, and then say, hey, this is why I'm better than Angular. Or based on your application, my strengths are this. Another thing from Google is DOM manipulation. So you saw in that click handler, in order to do that click callback, when I click on that list, that anonymous function, you are relying on the DOM. A big thing that Angular pushes for as an MVC is that you shouldn't have any DOM manipulation in a controller, or you shouldn't have far-reaching DOM manipulations. It should all be in a directive that manipulates the DOM. By removing DOM manipulations from your application logic, it will make your code way more testable. A thing that I learned very quickly, or a good example of this that I stumbled upon right when I saw this is, in one of my switch casements, I was switching based on a category ID. Category 1, do this. Category 2, do this. Category 3, do this. Well, in that case statement, I was also setting CSS of a DOM element. So I went to unit test my category handler, exception. I was trying to select an element from the DOM and then set its style. So I had this business logic that says, based on category, do this. I was also trying to do view manipulation. So Angular is a framework that's built in a way that discourages you from doing mistakes like I did. This right here, so separating the DOM from app logic. What do you feel is wrong with this code? I'm going to be devil's advocate and say this is extremely, extremely bad JavaScript code from a testing perspective. What's wrong with it? I've written plenty of code like this, and I would say it's bad. Yes. It's JavaScript and the projector's colors are a little weird, but basically, yeah, go on. Okay, that's one. Anything else? Okay, yeah, and hard coding results. I'm assuming results is there. Basically, what I have is my data access layer, my model, my controller that's saying, hey, once my stuff comes back, go update my view. This isn't bad code because it works. I would say it could be better code based on the way you write it. So instead of having this nesting block, you have to read through what it's doing. Whereas you could be writing code that's broken out into functions. Get customers, this is your data access. All it does is it returns the promise from get JSON. Then you have display customers, which is strictly your view. Based on some data I passed into this helper function, then loop over and print it out. And then you have your controller that basically calls your helper functions. You can unit test this, your data access layer. You can unit test your view, which I think is dumb. But what you can do is see how your view behaves, passing in all kinds of different formats. What happens if I pass in an empty array? Well, if you wanted to do this back here, what happens when I empty array? You're gonna have to change your web service to see what happens when it has an empty array. You could unit test this with an empty array, unit test it with an object passed in, unit test it with 100 customers. See what happens. You don't have to change your view to see what happens here. What you could do is take these implementations and move it into some module you don't care about. And at the highest level of your application, you can just read this. You can read, hey, get customers, and when you're done, display them, instead of having to read code like this. This is a very small amount of code, so it's easy to take in. But if you have a complex web application, good luck if you have 300 lines of this. It's much easier to break out functions into components and modules and then abstract all the details to just have the minimal amount of code at the highest level possible. So by separating your DOM from app logic, it makes your code way more testable and readable. I'm going to skip this video. Well, screw it. Let's do it. I think we're doing pretty good on time. Let's skip it. We'll come back to it if it's important. There's something weird going on with my clicker. Man, come on, I really want to see it. Let's see it, I think. So so this is a unit test runner. This projector is kind of in bad shape, but basically what you have here, you can't really see it on the screen, but this is a console. This is in the upper right-hand corner. This is your unit test right here. This is your described it expect, and this is your implementation. It's impossible to see with this projector. But basically, I'll play it really quick. But what we have going on here is you see right here, it says test failed. Well, you can see me typing in here, and as soon as I save that file, my tests are rerun. I can then bounce back and forth between my test file and my implementation, and in the background, my tests are just running. So this is one of the benefits of, and this will speed up the way you write tests. This is using Node and Gulp. Node is in the background, Gulp is my task runner that is basically saying, hey, watch these JavaScript files. I'm basically saying anything in the JavaScript directory, watch. On change, one of my tasks is rerun my unit tests. So anytime an implementation changes, it's just there running in the background. Sorry, it's weird. And integration testing. Basically with components, the way I generally break it down is with required.js, I break out my components into it's either all module, all view, or all controller. And then you generally have controllers of controllers, and required.js goes out and like asynchronously downloads all the dependencies. It's an integration because you're bringing two or more components together. You can also consider an integration test as, hey, I'm actually hitting the web service. I'm no longer mocking out the customers that are being returned. I'm actually hitting a third-party web service or even my own web service that I can't control. I'm testing API endpoints. So this is an app that I built here using Jasmine Form Validator, individually testing the validation component of my form. But then there's data access tests. So perhaps you had this run, data access sometimes goes down. Infrastructure changes, web service changes that maybe, one thing that happened to me is I was using Twitter's version 1 of their API for one of my apps. And all of a sudden, they said, we're no longer using version API or version 1. You have to use OAuth. And we're deprecating version 1. And I went to use my app and it broke. You can have some kind of timer job that occasionally tests your data access points so you would know if something has broken behind the scenes that you have no control over. Think of a weather service. You're hitting some third-party web service Do you want to know about that web service going down and not working before one of your customers report it? Test them. Test your endpoints. It doesn't hurt to. End-to-end testing. You can think of end-to-end testing as an integration test, but it's basically end-user interaction. So when your user clicks that button, what happens? When that user does whatever, what's the experience? End-to-end testing is very much like Jasmine. It will. This is actually using protractor by Angular, and you see describe it, and then there's something special here. Within the it, you're saying I want to get some DOM element by CSS by the button pseudo selector, and then you're saying click. You are simulating the end user's interaction. It's an end-to-end test, and then you say I have an element. That's simulating a click on a button. But let's say you want a user to type in a text field. You can say, let's say this is Angular, and in your Angular template, you gave it an ng model of input. So you're saying by model and the scope, select the input property, and then send the keys test. This will take the text field and send test. Now, in the background, Protractor is using Selenium WebDriver. Why don't you just use that? Fine, use it. But one thing that's nice with it is that if you're writing your application in JavaScript, you don't have to switch over to like a Ruby Cucumber-esque environment and do it in a separate programming language. This allows you to write tests as you write your app, if it's JavaScript. Test coverage and metrics. So this is one thing that I just implemented today, and it's actually working on dev, is I'm saying whenever the global window variable sees an error, send an XML HTTP request to some data store. So as soon as your app experiences a JavaScript runtime error, you're going to hear about it from that post. And you can get the message and the URL and the line number of that error. So that way, as soon as something breaks, it's in your database. What we're doing in SharePoint world is we have a list that we're posting to, and we put an alert on that list. So as soon as the list item gets added, it's like, yep, we have an error in one of our apps. Istanbul is a code coverage tool. I think this isn't I actually don't like this image. I just want to rebuild a new one. But this is saying that in this, let's call it a module, we have this amount of coverage in common. Tree map code view. So you can consider this a heat map of components. So let's say this component is extremely important to you, it's fundamental to your app, and it's red. What this is telling you, hey, it might be a good place to test right here. What I'm getting at with this is it's not okay, or it's not that important to test everything. I mentioned earlier that testing your view is kind of lame. Your views and CSS, etc., what the app looks like, it's better, in my opinion, to test that visually. It's more important to test your model, which contains your data access and your business logic. Make sure those things are 100% working first before you test your view. The Telerik controls has something very cool. It's a paid for service. What I was talking about, that XML HTTP request, is basically this. We're saying, hey, there's been 199 defects and these things are still happening. But what this is saying is we've seen this exception 151 times. If it's happening a lot, it's basically saying you should probably fix this first. There's very nice metrics like the first time it occurred and the last time it occurred. It helps you prioritize fixing defects that you already know about. When test, you should always have at least one test for your app. If you're writing apps and you don't have at least one test, maybe in your next project, figure out how to write a test for it. Have at least one test, because once you figure it out, it becomes more and more easy, and it also becomes more natural. Figuring out, to me, that was the hardest part. How do I write my JavaScript in a component manner? Then how do I test those components? Then how do I deploy those tests? And this goes back to the go-to fail bug, test your algorithms. Those, to me, are the easiest places to test. If I'm writing some kind of data processor or business flow, it's very easy to test that. I hate this graphic. This is why you should test. I think I'm going to take this slide out, actually, but I hate this graphic. It's just overused. I see it everywhere. But the reason why, right, The reason why you should use it is because this is how the customer explained it, and this is how the programmer wrote it. Between those two components, the way the customer explained it and the way someone coded it, there's so many other factors that will cause your code to change and cause you to refactor. And when you change stuff, other dependencies and other things break. It's only natural. I've experienced a lot, and I'm sure many of you guys have too, where you wrote something that works, there's a change in requirement, and now something broke. It's a bug due to a change in requirement. Lessons learned. A big thing is I was writing all these components and I was the only one using them at first. But as I had more and more components that were reusable, the same problems came up. Think of a message handler. So when I hit a web service, you want to say a message to the user, thank you for submitting this form. Or if there's a failure, there's an error submitting your submission. That's one of the components that I wrote, and then the component's like, oh, I need something like that. I have that. It works perfect. I'm using it across like 3 or 4 projects. All right, cool. They use it, Fahey, it's not working. Like, what? Like, come on. Well, what it boils down to is I was passing in a string, and they were passing in an object. And that's going to cause something to break. So don't always assume that you are the consumer and the producer of your modules. It may be that way at first, but just because you wrote it doesn't mean you're going to be the only person using it. Monitor your production code for exceptions. I'll touch on this. It's okay to run your tests on production. Figure out a way how to deploy code to production and run it there. I'll show you an example of it. If you can run your code on production and you can feature toggle your tests, what you're doing is you are exercising your code on production. Why is it important to test on production? Is because your users are essentially testing your code on production. Each time your user uses your app, they're essentially testing it. When you deploy your code to production, you can't just assume that it works because it worked on a lower environment. It's real life to have a code in a lower environment that runs like a charm, and you deploy to production and something just doesn't work. Figure out a way how to deploy your JavaScript code to production and test it. Don't be this guy. Yeah, it sounds crazy to test in production, but don't be the guy that never even writes tests. I'm gonna skip on this really quick. I just wanted to show some quick examples of testing on production. I think Wes kind of gave me like a WTF what? Or you're just squinting at the slides because you can't see it. Neither. So an example of testing on production. So we made an app at Nationwide really quick called Fancy. This is an internal URL shortener. So basically, yeah, so basically when you put a URL in, you give it an alias and it's a shortened named. Simple analytics that show the access count, like how many times this has been accessed. So this is, when you go to that URL, it's been accessed 4 times, the last time it was accessed. So if you go, again, this is SharePoint, sorry. But if you go here to your site pages, you'll see there's a page called Fancy's Tests. So what I can do, and there's not a whole lot of tests, you can see them running. There might, due to the VPN, one of them might fail. There's a performance test. There's 15 specs and 1 failure. And you can see the timeout. So it was not invoked within a timeout period. But what I can do is I can see 14 of my tests that are passing. And I think I can ignore this test. I kind of want to just ignore it. Hold on, let me see here. Just ignore it, yeah. Yeah, so basically what I know is that I have 15 specs passing. You saw it in one of my screenshots that they were all passing, but it's a performance thing due to the VPN. But how do you deploy your code and not have your users get to it? Since in SharePoint, in this case, it's a feature. You can deactivate the feature. Just completely remove the test completely, or just make this a permission page. Only site owners can get to this page. So what I would like to do is get to a point where we get more funding, naturally, and build this out a lot better. So those tests run every day. So let's say this is supporting IE8 right now, but we're gradually rolling out IE11, and they're always changing the IE11 configurations and security policies. So if something breaks into IE11, I could know about it before someone reports it. Another thing is, let's see here, error reporting. So this is another thing that I'm trying to roll out as soon as possible. Let's see. So can you guys see this okay? It's SharePoint, yeah. So basically what we have here is 2 separate site collections. So let's say, I'm gonna delete these fellas. So we have a site collection right here called build and a site collection over here called fancy. Now, this is an error reporting list. So basically, if there's a runtime error, let's know about it. Over on this site collection, I have a tester where I can say generate error. So you'll see in the console, sorry, when I click this button, an error happens. It's a runtime error. It happened in the global window. If I come back over here, it's really simple. I have the report of uncaught error, test error. I get the line number it happened, the page I was on, and what browser I was in, and it was created a few seconds ago. This was probably, it's less than about 30 lines of code. It's a simple window.on error, and when that happens, post to this URL. It's pretty simple. So this is something really simple that you can't really see it, but womp. It is, sorry, 62 lines of code. This is using window, man, this projector is really bad. Yeah, screw it. But you can. Yeah, so basically there's a required module and it basically is saying set up the error handler and add to list. That's all that's going on there. But what this will allow us to do is, hey, if there's ever an error, a runtime error in one of our apps, if we deploy code, we're gonna know about it before someone reports it. We're gonna put an alert on that list that sends an email immediately to us. Hey, something's new in this list, go smell what's happening. This will be helpful when we install. So think about upgrades. This happened to us last week. We installed SharePoint 2013 Service Pack 1. They changed the DOM on us in our, forgive us, but we were doing some DOM scraping based on something we had to do because it's SharePoint, DOM is dirty. But we were scraping some DOM, and in SharePoint 2013, they changed that DOM. 3 people contacted us, this isn't working, this isn't working, this isn't working. And it took 2 or 3 days before people reported it. What could have happened is how many other users had that problem before they reported it. Yammer SDK, Yammer upgraded its API. And our app market, where people go and installed apps, it was breaking. We didn't hear about it for 3 or 4 days. But we had analytics that showed 200 or 300 people went to that page before someone reported it. Whereas if we had something like this, the real-time monitoring of our production code or running our tests on production, we would have found out about it before anyone else reported it. So I'm going to skip the Angular section of the presentation because I kind of want to GTFO, and I've been talking enough. Before I go on, is there any other questions, concerns? I'm sick of JavaScript. I'm sick of you.
Some more gold way to log finding errors.
There's no gold way. I would say it strongly depends on your platform. Since I'm using SharePoint.
The global.
Global.
Something that's not nationwide specific.
So yes. So what you could do is fire up a Firebase instance, and in your app, all you really need is window.on error. So there's nothing nationwide specific about this except that it's deployed to nationwide SharePoint. So I kind of want to bring it up, but I just know it's so bad. Basically, what you do is
change your color theme.
yeah. Oh yeah, that's right. Where do you go that at? I know we've done this like 100 times.
Right there. So it's right there. There's a drop down line.
Boom. Light. So then how do you zoom in? The control. I don't have a wheel though. The fuck? Control. I think I'm on a VM and it's not. There we go. Screw it. Let's do it this way. So the only thing that we're doing is on here, we're saying error reporting is my class, if you will. JavaScript is prototypal and inheritance. I say set up error handler. All I'm doing is saying the global window variable on error. That callback gives us the error message URL and my number, and I have reporter.add to error list. So all you need to do right here is an XML HTTP request to whatever. Amazon, Firebase, your web server. Yeah, you could spin up a MongoDB database on your instance and provide a web service endpoint that allows posts. And you're good. Maybe add a get so you can get all your recent logs too. But this is something very easy to implement that I think will be very helpful for us, because it really bugs me when there's an error or a defect that maybe we need to change a character, and it's been happening for 3 or 4 days, and people at Nationwide hate calling ITSD or creating a ticket. Screw it, it doesn't work, bye. That's enterprise. Think about outside of the enterprise. If you're launching a new app and something's breaking, or you're selling something on your website and your checkout is breaking, you don't want someone to report it before you can fix it. You can find out about it by doing something as simple as this. Angular, it actually captures all your runtime errors. Your errors in Angular never reach the window. They bubble up to the app or whenever your ng message directive captures it. You can then do a XML HTTP request there. But the big thing is figuring this out. Figuring out how to test, or figuring out how to write components, figuring out how to test them, figuring out how to deploy it, figuring out how to monitor it. This is just SharePoint. You can do it with your apps too and your platform. Right, so Google Analytics was not an option to us. We're actually using a tool called Hairpoint, where you can push any JavaScript thing you want to there. Google Analytics is coming to our group. You can push it to whatever. You would do a ga.push, and then you put in your API keys and secrets and all that stuff. You could do it there. But that would be a very easy thing to hook into. That's a free data store that you don't have to even build anything. You just have to write code or configuration code. And I think Google Analytics will do this for you too. I think in your configuration dashboard, whatever they call it, you can say monitor for runtime errors or something like that. All right. Thank you.
Is that it?
Yep. I know. I'm talking too much.
Oh, yeah.
Whoa, JavaScript.